Today's customers have an increased awareness and commitment to quality and service. This places new demands on dealership technicians who are trying to achieve a high level of customer satisfaction. To assist the technicians in meeting this demand for service excellence, the Ford Parts and Service Division has introduced the Service Technician Specialty Training (STST) program. While developing this improved approach to service training, the technical training staff consulted with the training subcommittee of the National Service Managers Advisory Committee, as well as the District Service Engineers Advisory Committee. The result is a training program that will make available to Ford and Lincoln Mercury technicians the information and skills necessary to fix it right the first time. A full menu of new courses are being developed to fully train technicians in these specialty areas: engine performance, engine repair, suspension and steering, electrical systems, climate control, manual transmission and drivetrain, automatic transmission and drivetrain, brakes, and pre-delivery. Training schedules provided by your district office will announce when courses relating to these specialties will be offered.
On the road, Ford and Lincoln Mercury are a step ahead of the pack in automotive engineering excellence. And in the service department, you can use this new model service training material to keep one step ahead of the most significant new product features and service procedures for 1991. Here is a quick reference index of what you'll find in this training production.
First, the traction assist option on Lincoln Town Car for 1991. Its operational theory, the components and their location, and diagnosis of the new system.
Next, the front suspension changes to Town Car, how it differs from last year's design and advantages in both adjustability and serviceability.
Updates on airbag system diagnosis and repair on all Ford and Lincoln Mercury models will be covered in the next segment.
Next, we'll cover the new C3 power steering pump, how it differs from its C2 predecessor, and serviceability of the new unit.
A new semi-automatic temperature control will be covered in the next segment, followed by a section on refrigerant recovery and preliminary information regarding the anticipated changeover to the new 134A refrigerant.
And the final segment will cover the return to standalone speed control systems, the reason and the process for diagnosis.
To make it easy for you to reference the service sections that will affect your job, each of the 7 topics will be covered separately. Each of the videotape segments will be preceded by a title frame, which will describe the segment and remain on your screen for approximately 5 seconds.
New Lincoln Town Cars equipped with the optional 4-wheel anti-lock brake system will also feature a traction assist option in 1991. Traction assist is essentially an extension of the anti-lock brake system, but operates during acceleration. The control circuitry identifies when either of the rear drive wheels begin to spin during acceleration. Then, the ABS module rapidly pulses the brake on the affected rear wheel until traction is reestablished. The traction assist, or TA, remains operable up to approximately 25 miles per hour and decreases gradually until it becomes inoperable at about 34 miles per hour. The system also prevents brake overheating by monitoring the frequency of TA operation, and traction assist becomes inoperable whenever the brakes are applied. Traction assist componentry is simply an extension of existing components for the anti-lock braking system. An electronic control unit, or ECU, is located in the engine compartment on a bracket attached to the radiator support. The ECU monitors the speed of all wheels via sensors at each wheel. However, on TA-equipped cars, the ECU microprocessor has added logic over ABS-only models. In order to detect wheel spin during acceleration, it uses the speed of non-driven front wheels as a reference point. The ECU then controls the hydraulic control unit, or HCU, located in the front of the engine compartment on the left-hand side below the air cleaner. The HCU delivers pressure to apply the rear wheel brakes. However, unlike vehicles equipped with ABS only, the HCU for traction assist contains two additional valves. Isolation valves, which close during traction assist cycling to prevent fluid from entering the front brakes. You'll notice during the service that the HCU on TA-equipped vehicles is visibly longer than units on ABS-only models, due to the addition of the two isolation valves. Aside from the new HCU, traction assist depends upon existing ABS components for its basic functions.
The Lincoln Town Car for 1991 features significant changes to its suspension system components for better handling, a smoother ride, and improved serviceability. A major modification is the new non-adjustable, non-serviceable sealed front wheel bearing and hub assembly. The bearing and hub assembly rides on a redesigned forged wheel spindle which incorporates additional positive caster angle for improved tracking. And the spindle mates to a new upper control arm and ball joint assembly that allows a broader adjustment range during wheel alignment. Also new on the 91 Town Car is a new front stabilizer bar system. New tie rod type end links have replaced the clamp type links. These new double ball joint links are fastened to the wheel spindles and provide a 1-to-1 ratio between vertical movement of the wheel and deflection of the bar. Two versions of the new stabilizer bar are offered, one for standard applications and another for use with the optional trailer towing package. The 1-to-1 stabilizer ratio was used first on the Taurus Sable and Thunderbird Cougar lines, and now the Town Car will benefit from the improved roll control and flatter cornering it provides. In terms of serviceability, these new suspension components are measurably improved over previous designs. For ease and alignment adjustments, the new control arm assembly has two sets of cam adjusters on top of each upper control arm. Caster adjustments are made with the inboard cam adjuster, and camber is controlled with the outboard cam adjuster. The combination allows front wheel caster and camber to be adjusted independently of each other. And note that the engine compartment has been redesigned to allow easy access to the adjustment cams. Contributing to improved durability are upper control arm and stabilizer bar ball joints that are sealed and lubricated for life. The sealed front wheel bearing and hub assembly is also lubricated for life. Sealed, pre-lubricated cartridge-type ball bearing sets replace the tapered roller bearing design used previously, eliminating the need for periodic repacking. And if it's determined that the bearings are worn beyond acceptable limits, the bearing and hub assembly is simply removed as a unit and replaced. Complete details on suspension system adjustments and service are listed in Section 1401 of your shop manual.
Ford and Lincoln Mercury take another step forward in passenger safety in 1991 with service and diagnostic refinements to all models equipped with the Supplemental Airbag Restraint System, or SRS. First, future models equipped with SRS will include a backup power supply module containing a discharge for service circuit which disconnects all firing power from the airbag system during service. After the battery positive cable has been disconnected for 2 minutes, a capacitor in the backup power supply will discharge completely. Remember that while other electrical service may require only disconnection of the negative battery terminal, disarming the SRS requires that the positive cable be disconnected. Next, the new SRS will contain an integral diagnostic monitor. Identifying of specific system malfunctions may be accomplished by means of a new fault code scheme. Actual application of the new system on certain vehicles will be a running change. Refer to the appropriate service manual for SRS information on specific models. The clock spring contact mechanism within the steering wheel hub on SRS-equipped vehicles is an inherently superior method of maintaining electrical contact. Yet, contact failures due to broken clock spring tapes are often caused by failure to properly center the clock spring during reassembly. The key to proper clock spring installation is to remember that when the spring is properly centered, It's designed to withstand 2 1/2 turns of the wheel from the straight-ahead position in either direction. But if the spring is rotated out of the proper centered position during installation, the spring tape may break when the wheel is turned in one direction or the other. Here is the proper procedure for R&R on the clock spring. Before beginning the procedure, disarm the airbag system using the steps we just covered. Next, the steering wheel removal. Center the car's front wheels to the straight-ahead position. Then, remove the 4 airbag module retaining nuts and lift the module off the steering wheel. Disconnect the contact assembly airbag wire harness from the airbag module. Next, disconnect the contact assembly control wire harness from the steering wheel. Remove the steering wheel retaining nut. Then use a steering wheel puller to remove the wheel, being careful that the contact assembly wire harness passes freely through the hub as it's lifted free of the shaft. Be careful not to damage the wire harness during this step. Now, the contact assembly removal. Be certain that the front wheels are in the straight-ahead position and the steering column shaft alignment mark is at the 12 o'clock position. Remove the instrument panel, lower trim panel, and lower steering column shroud. Then, disconnect the contact assembly wire harness. At this point, apply a piece of tape across the contact assembly stator and rotor to hold them in alignment. Finally, remove the 3 contact assembly retaining screws and pull the contact assembly off the steering column. Now for the contact assembly installation. Again, be sure that the front wheels are straight ahead and the steering column shaft alignment is 12 o'clock high. Align the contact assembly to the column shaft and mounting bosses and slide the assembly in. Install the 3 retaining screws and torque to 18 to 26 inch-pounds. Route the contact assembly down the column assembly and connect the wire harness. And if the contact assembly is new, remove the lock mechanism. Finally, install the steering wheel. Again, check for straight-ahead alignment. Route the contact assembly wire harnesses through the steering wheel opening at the 3 o'clock position. Then position the steering wheel on the shaft. At this point, the wheel and shaft alignment marks should mate. Install the retaining nut and torque to 23 to 33 foot-pounds. Connect the speed control wire harness to the steering wheel and snap the connector assembly into the steering wheel clip. Connect the wire harness to the airbag module and install the module on the steering wheel.
Performance and reliability are the motivation behind the new C3 power steering pump, making its debut on Lincoln Town Car for 1991. The C3 pump features several advantages over its predecessor, the C2, beginning with its mounting directly to the 4.6-liter V6 engine block, an industry first. Direct mounting means more precise pump positioning and less chance of misalignment with the serpentine accessory drive belt. Size and weight reduction are another plus for the C3 pump. The C3 is a vane design, in contrast with the slipper design of the C2. This allowed a reduction in pump size while maintaining flow and pressure requirements. In fact, improvements in the flow circuit provide a 20% improvement in assist while reducing horsepower drain. And the vane design reduces pressure spikes. That plus a quiet pressure relief circuit reduce pump noise by 50%. The C3 pump also incorporates straddle bushings, allowing the shaft to pass through the pump's center line. In contrast with the C2 pump, this design allows higher belt loads and truer shaft rotation. Reliability is the object. Leak resistance should also be improved with the C3 by virtue of a decrease in the seal area, in reservoir filters, a vented shaft seal, and quick connect fittings. And finally, the C3 power steering pump features a remote, translucent fluid reservoir to ensure proper fluid fill at the factory and facilitate quick checks during maintenance visits. You'll find complete details for servicing the new C3 power steering pump in Section 1401 of the Lincoln Town Car Shop Manual.
Passenger comfort and convenience will be improved for 1991 with the addition of an optional semi-automatic temperature control system, or SATC, for all Thunderbird and Cougar models, excluding the base Thunderbird. SATC automatically maintains a pre-selected interior temperature by regulating discharge air temperature and fan speed, while the location of the discharge airflow is manually selected by the driver. When the fan lever is positioned on auto, the system automatically selects the correct fan speed to maintain a preset temperature. In cool weather, when either vent or heat floor are selected and the fan lever is on auto, the fan will remain switched off until the engine is warm enough to provide heat. And while the fan is off, the fresh air recirculation door will force recirculation to prevent cold drafts from entering the interior. If the interior temperature is higher than the preset temperature, the blower will switch on. However, the fan can be set at a fixed speed by switching the lever manually. Pushing the cool or warm button will lower or raise the temperature 1 degree with each push until temperatures of either 65 or 85 degrees are reached. At that point, one additional push on the button will trigger a 5-degree drop or jump. The selected temperature is digitally displayed on the control panel. When the ignition is switched off, the screen goes blank, but SATC remembers the pre-selected temperature, and when the ignition is switched back on, the preset temperature shows. The SATC system monitors temperature by way of an ambient sensor, a sun load sensor, an engine water temperature sensor, a unique control assembly, and a unique evaporator assembly. In the event that the SATC system malfunctions, a code, E2 through E9, will appear on the digital display, and the owner's manual indicates that dealership service diagnosis is required. A key SATC feature is intermittent diagnostics. If a system failure occurs but corrects itself, the controls may operate normally, but service diagnosis will reveal a code from P2 through P9, which corresponds to the E code the customer may have noted. Once the technician follows up on any problems with the system, the P code may be erased from the display by depressing the Cool button for 3 seconds. If not erased manually, the P code will self-erase after 100 ignition cycles to eliminate the possibility of subsequent troubleshooting for a problem that's already been solved.
Increased concern for the environment has prompted several phase changes to Ford and Lincoln Mercury climate control systems and service procedures. And recycling of reclaimed refrigerant is high on the list. The recovery equipment used may vary between dealerships. Some dealerships may have received the Murray Recovery Unit. Later deliveries will be the Robinair Recovery Unit. In either case, the refrigerant recovery station is designed for use with a manifold gauge set or with a charging station. After the AC system has been charged, refrigerant should be recovered from the manifold. However, this step is unnecessary if the manifold is equipped with quick seal fitting hoses. When the tank is full and recycling or recovery is complete, use only charging equipment which draws liquid out of the tank. Note that the recovery compressor is not a vacuum pump, and only a vacuum pump will totally evacuate the system. An impending worldwide ban on chlorofluorocarbons, or CFCs, has triggered a gradual phase-out of AC systems designed to use R12 refrigerant compounds. Preliminary plans call for the replacement of the R12 compound with R134A refrigerant. Because R134A has different characteristics than R12 when used as a refrigerant, major modifications to AC system components will be required. A redesigned compressor, evaporator, and condenser among them. Further changes may also be necessary. Of course, millions of systems using the R12 refrigerant will remain in service. And to minimize atmospheric damage, more accurate diagnostic tests for system leaks will be developed. One such test is the on-vehicle condenser and evaporator leak test. This procedure should be completed before blaming an evaporator or condenser for leakage, because chemicals other than R12 can activate an electronic leak detector. This test requires the use of adapters from Leak Test Adapter Kit D88P19703B on the two fittings of a component to be tested, allowing vacuum to be applied to the component through a manifold gauge set. If vacuum cannot be maintained, a leak is present. For complete details on this procedure, refer to Section 3632 of the appropriate shop manual. Other potential sources of R12 leakage are in the various spring lock and threaded couplings in the system. It's important that the O-rings used at these points be correct in both size and composition. Otherwise, premature degradation of the material and leakage may occur. Correct part numbers for various size spring lock and threaded couplings are listed in your video reference book.
Several Ford and Lincoln Mercury model lines will be switching from integrated speed control systems back to the so-called standalone speed control over the coming year. The switch back from an integrated vehicle speed control system to the standalone system is not due to any faults with the integrated design. Rather, it is because vehicles equipped with AXODE transmissions require that the EEC4 processor pin, formerly occupied by the integrated speed control system, must now be utilized for transmission control purposes. The standalone system is not new. It's been used on vehicles during past model years. Rather than using the EEC system, the standalone arrangement relies on a separate module, an amplifier in either the low-gain or high-gain version, the rating indicating how quickly each amplifier reacts when the speed set button is depressed. These amplifiers are not interchangeable and are color-coded for that reason. The location of standalone amplifiers varies between models. On Tempo and Topaz models, a standalone amplifier with a black case is located behind the lower front instrument panel cover.
In Thunderbird and Cougar models, the standalone amplifier has a natural color case and is located at the brake pedal support bracket. And a vacuum servo with integral throttle position feedback potentiometer is located at the left front of the engine compartment behind the fender.
On Taurus and Sable, an amplifier with a natural color case is located behind and to the right of the glove box. And the vacuum servo is located at the left-hand shock tower inside the engine compartment.
On Crown Victoria and Grand Marquis, you'll find an amplifier with either a natural color or dark brown color case, depending on whether the vehicle is equipped with a standard or electronic instrument cluster. In either case, the amplifier is located on the instrument panel bracket between the steering column and transmission tunnel. The servo unit is located on the left-hand inner fender, and a vacuum reservoir is located under the front bumper at the left front impact absorber.
On Lincoln Town Car, an amplifier with a natural color case is located behind the glove box. The servo is located on the left-hand inner fender, and a vacuum reservoir is mounted under the front bumper at the left front impact absorber.
And on Lincoln Continental, you'll find an amplifier with a natural color case located behind the glove box, while the servo unit is located at the left-hand shock tower.
Before diagnosing problems with a speed control system, always be certain that both the vehicle's horn and stop lamps are operating correctly. Failure of either the horn relay or stop lamp bulbs will cause the speed control system to malfunction.
Remember also that your dealership should already be equipped with a Rotunda speed control tester. This system will test virtually all major components within the standalone speed control system. And complete details on speed control diagnosis are found in the appropriate service manual or technical service bulletin.
That covers the key service features you'll need to know as the new models roll into the dealership. Be sure to consult your service manuals and technical service bulletins for detailed information covering all the new vehicles from Ford and Lincoln Mercury for 1991.
Early 1991 new model training is available at district training centers covering the early release vehicles Escort, Tracer, Capri, and Explorer. The upcoming new model materials covering Ford new model service features, Lincoln Mercury new model service features, 4.6-liter modular engine unique features and service information, AXODE automatic transaxle theory and diagnosis, steering, brakes, chassis service will be sent to your dealership in August at no charge, so watch for release dates in upcoming messages on Oasis and in TSBs. contact your district office for any further information regarding new model training.